semester 2 week in 51 group for our cloud native food ordering and delivering system project, which is named Yum Yum. Let me quick walk through my workflow, customer order placement workflow. From here, customer can register to the system, and the customer registered early, he or she can enter their credentials by here and log into the system. It was handled by our login page and the submit section. Then once customer navigate to the home page, the customer can add their delivery address using Google Maps API coordinates automatically generated based on the entered address. Then the customers can now browse verified restaurants and their menus by here, and our backend in restaurant controller. Restaurant control handles the fetches this data from the restaurant service, organizes it and sends it to the front end. And when the customer adds item to cart, it's done from here. Here customer can add items to cart, then it displayed here and here, and it was handled by cart context, allowing items to be added, updated or removed, and totals be calculated automatically. Then proceed to check out. App displays all orders and customer details. When ready, the customer then customer can select payment method. Now I select credit or debit card. Then customer can place order. Then customer can add credit card numbers, expiration date, CVs, and here customer can pay. This is the order control code, which validates and saves ensuring all orders. And the order event is published to RabbitMQ, allowing other services like the restaurant admin and delivery services to be notified in real time. This is RabbitMQ code, and you can see the RabbitMQ dashboard, which handles the message queues ready. And for the card payments, our system is handled through Stripe, integrates with Stripe. The front end requests a payment intent. This is Stripe code and the customer completes the payment using secure Stripe 4. Once the payment is successful, Stripe notifies the backend and the payment status is updated to complete. The order is then sent to the relevant restaurant. The restaurant staff see the new order and accept it, confirming they can prepare the item. Then the order management service assigns the order to available driver. In here, customer can see the order status. That this is now finding drivers. Then it's assigned to the driver. You can see the driver details here. Meanwhile, the customer can track their order in real time using the app, using live updates from the backend and integrations like Mapbox for live location tracking. And here you can see our system is deployed using Docker and Kubernetes, which is microservice running in own container. This is sample Kubernetes code. Then you can see the API gateway here. Handles routing to the correct services and applies security measures like rate, limit, and cost. For the sensitive configurations such as API keys, we use .env file, keeping secret Mapbox tokens, Google Maps API keys, Stripe public keys, likewise things. So this is the end of my part.
Hey everyone, I'm Vidit Rapidu, and we are implementing a food ordering system. Its name is Yum Yum, and I am implementing the delivery drivers part. So let's move on to the demonstration. This is the front end, the delivery drivers front end. If you have the login credentials, you can log in. If you doesn't have the login credentials, you have to sign up. So I enter his full name, but I just don't name like that. Yes, phone number with 10 digits, password with 8 digits, and he has to choose particular his or her user's vehicle information, driving license, vehicle number, address, and then he can create an account. Yes. So let's log in as yes. Yes. This is the Yasas dashboard. So in this one, it shows the Yasas live locations, and I looked at Yasas. And what are the active orders, complete orders? Let's go first because time is going to have. I only have 3 minutes. So in the order, there's a pickup details, delivery details of the items. When I click the direction button, it will open in the Google Map, and I can go the direction like this. Yes, like this. And when I picked up the order, I have to mark as it picked up. Then delivery status will change as picked up in these two places. Then I have to, when I picked up, then I have to I have to deliver it. So when I go to deliver, I have to put the directions. Then see the first place I have delivered. Then I can use the direction button like this. Direction button. Then I can go like previous I show you. So after delivered, I have to mark as delivered. Then it will move to the complete tab and change the delivery order status as delivered. So that's a basic front end part that I implemented. User can see what other things the user can see things. Then let's move on to the backend part. Okay, there is an authentication service. The authentication service, there's four members in our team. We all use it for one authentication service. And there's one module for the different roles, but there are specific details like delivery driver special we have will use have to fill like this delivery person. There's another schema for that and routes. These are the routes register and looking. These are the basic things like this. And let's move on to the most important part. So I implement the system with RabbitMQI. RabbitMQI means it is a message broker system in internal services, internal synchronous services. So I implement the order system is implemented by my other team member in in my team. So I implement Rabbit case in this part like this, and when order is going to create, when order is going, this is the controller function. This is controller create control function in ordering part. I implement when it's going to create, it publish to the queue or the queue with these details, and after that it create an order. So that's creating a or queue name or queue and publish the details. Then so then order service will act as a publisher and bypass it. I implement the delivery service part. In that part also I initialize the rabbit like this. So delivery consumer is the consumer that will consume all the order details from the queue. Like this, I'll listen to the report and then I'll consume all the details from the order queue and just disable console log to check that I correctly logged. So this is how I communicate with users. So and I show the modules, delivery module, order ID, restaurant ID, customer ID things, controllers, create deliveries, get all deliveries, update deliveries that I previously mentioned. Then delivery person update the orders delivered or this picked up, then status will automatically update. This is the routes that I created, and yeah, these are the basic things that I created. And next, the JS, I will implement the Rabbit QI, and yeah, and the Docker things that I have to use for the hosting things. So these are the basic things that I have implemented. So yeah, so I think you could understand. Uh, Thank you.
Hello, I'm Mean KIT. I have completed the payment service and admin service in our food delivery platform. When we talk about payment service, this service is responsible for securely handling customer payments using Stripe. The main goal of this service is to process payments when a user places an order. It communicates with Stripe to create and confirm payments and ensures that transaction details are stored correctly. So our payment service follows the easy architecture. It has three main parts: routes. These define the API endpoints, controller, and the model. So this is the payment controller. Here is the place that real logic happens. The create payment intent function gets the amount and currency from the front end. Then it uses the Stripe library to create payment intent. Then Stripe returns a client secret which we send back to the front end. This client secret is used to safely confirm the payment from the browser. So after a successful payment, Stripe notifies us. We then save the transaction details like order ID, amount, currency, payment intent, IDT, payment method, status, user in the MongoDB using this payment module. Uh, this is the route file that all the call routes are here. This post create payment intent is used to create a payment. And there are 3 get routes to get all payment intents, to get monthly revenue, and then get total transaction amount. So I have used Docker and Kubernetes to deploy my payment service, and this is the Docker file, and this is the payment deployment.yaml. It contains the deployment service name, the payment service, and the container port 5552. And this is the payment service.yaml. And this terminal console shows the deployment of the payment service is successfully done. So let's move on to the admin service. Here, this is the login page, and this is the admin dashboard. All the cards are real-time fetch the data from APIs of different services, verified restaurant count 8, 8 pending verification, the number of total users, and the total revenue. Also, those chart shows various type analytic data which are fetched from different services. This revenue growth chart shows the revenue growth in month-wise, and this is the role distribution pie chart. It shows the role count that registered when going to verify restaurants. This is the UI the system admin shows, and these are the pending applications. The system admin can approve restaurant applications. These are the verified restaurants, and also the admin can view all the details of the restaurants, and also the system admin can reject applications. When we go into user management, these are all the users that already registered to the system. We can see the users in role wise. The admin can filter out users by the role. Also can search users. The system admin can update the data of the users except the user role due to security conditions, which has successfully updated. Also, the restaurant system admin can delete users. When we go into analytics, these analytic data are fetched from different services using API routes. In here, we can generate report about the user role breakdown. This is the PDF. And we can generate the report on monthly revenue. This is the PDF of monthly revenue report. In here, the system admin can view all the transaction history. These are the transactions already have done. There are already total transactions of 53, but 31 are successful. Also, this card displays the total revenue. Also, we can export the payment transaction report. This is it. It includes all the details of a transaction. So that's it.
I will be a demonstration microservice based project that include auth service and the restaurant admin service. This is the middleware's models routes of the auth service, and these are the restaurant admin service models routes and the controllers. This is the Docker file, and these are the Kubernetes deployment YAML file. Both containerized using Docker and the deployed on the Kubernetes. Then let's move into the project. Then this is the dashboard of the restaurant admin. Once click this button, user want to add their name, email and the password. Then click the register button, navigate to the registration form. User want to add their restaurant details using this form. Then navigate to the login page. Also, user want to add their email and password in here. Then display this message, can't access the dashboard until the admin issue the approval. Then let's go to the restaurant that has received the approval. Then this is the dashboard of the restaurant admin. These are the orders of the restaurant. Orders can manage in here. New orders in display in here. Then click completed. Then display in here and notify to the user dashboard. These are the menu list and menu can add in here. That's all about in my uh, then my project, and thank you.